All right. Today's lesson is real quick and short. What we're doing is we are getting into solving quadratic equations. So we worked on graphing them in the last chapter. Now we have to solve these equations. These are quadratic equations in one variable. They can be written in standard form. Okay, ax squared plus bx plus c in this case equals 0. And we always want to get this thing equal to 0. Note the caveat, a cannot equal 0 because if a is 0, then 0 times x squared would be no x squared, so it would no longer be quadratic. Remember, quadratic means it's an x squared equation. Now, what we're looking for are the solution or the root of the equation. Quadratics in general have two solutions, and we play little games to make sure they have two. But you'll see as we graph them what those solutions are that we are looking for. So here's our first example. Now, don't worry about the graph over there. We'll talk about that in a second. So I want to find out what x is in order to substitute it in that would make it true to equal 0. This is a pretty tough equation to solve. I can't just isolate one x because I got an x squared term and an x term. So what we do is we graph the things. Now to graph them, what you want to do is get them equal to 0, and then you just graph its related function, which is y equals x squared minus x minus 6. Now what this does when I graph it is the graph will show all the x values and the resulting y value based on that x. And so here now I've graphed that function using Desmos. You could use any graphing program you want or a graphing calculator. We could also graph this by hand, but that takes quite a bit of time and we're not always great and accurate. So I've graphed it here. And then you can see the parabola. You can see it's decreasing here, reaches its min, and then it increases here. But the question is, what is the x value? Remember this green equation that makes it equal to 0. And I've just touched my graph at these 2 points because, hey, those are the x-intercepts of the graph. And so, the answers, x is either negative 2 because if I substitute a negative 2 into this green equation, I'm going to do it here. Negative 2 squared is 4 minus negative 2, so that double negative gives me a 6. Take away 6 equals 0. Negative 2 is a solution. The other solution is the other 0. In this case, x equals 3. I'm going to substitute 3 in here really quick. We'll do it in red. 3 squared is 9. Minus 3 plus 6. 9 minus 3 is, minus 6 here. Thank goodness. Otherwise, it wasn't going to work out. 9 minus 3 is 6, and 6 minus 6 equals 0. Yep, 3 is a solution. Those are my two answers. So all you're looking for are these zeros or these roots, the x values that make the equation actually equal 0. Now, they aren't always quite that simple. For example, this equation right here, example 2, it does not equal 0. So what you do is you just do a little manipulation. We're going to subtract the 4x. We're going to put it into standard form, 2x squared minus 4x minus 2. Now it equals 0. And we graph its related equation, which looks like that. And you can see I have it graphed right here. And let's look for the zeros. Okay? In this case, this parabola only has one solution where the x or the y value is equal to 0, and that's when x is negative 1. So the solution, x is negative 1. Let's test that real quick. I'm going to rewrite the original equation down here so I can show you all the substitution. So it's negative 2. Now x is negative 1. Just checking to see if it works out. Does it equal 4 times negative 1. Let's compare the left and the right-hand side. Negative 1 squared is 1, so negative 2 times 1, negative 2 minus 2, negative 4. The right-hand side, 4 times negative 1 is negative 4. Yep, left side equals right side. We are guaranteed that x equals negative 1 is the solution to that equation. So again, we're just looking for these x-intercepts. As long as it equals 0, you got to make sure it equals 0. If it didn't equal 0, you just have to manipulate it so it does. In this case, this function equals 0, so again, we graph the related function, x squared minus 8x plus 12. And there it is. And there's our solutions. X is 2, x is 6. So we have 2 solutions for that equation. All right, so you are going to have to rely heavily on Desmos unless you want to try and graph all these by hand. But all of your iPads have Desmos, or computers, you can just go to their website, desmos.com. And or when you graph problems like this previous example, your graph would just look like this. Mark those intercepts, 1, 2, 3, 4, 5, 6, so 2 and 6. We know it opens up. You don't have to be perfect with this, but just make a quick sketch. Say, yeah, there they are. I know the solutions are at 2 and 6. And that is it. Good luck with the homework. Example, kind of a strange one. Here we go. In this case, you notice our equal sign here, but it doesn't equal 0, so we got to move all that stuff over. You could take the half x squared to the right-hand side if you wanted to. I'm just going to move everything to the left. 1 half x squared, I'm going to subtract the 6x from both sides. So it moves it over to the left. I'll add the 20 to both sides, so it moves it over to the left. So there's my equation. I'm going to write the related equation with y equals 1 half x squared minus 6x plus 20. And you can see, here it is up there, and I've graphed it. Now notice this one does not cross the x-axis anywhere. And that means there is no value for x that we could put in here that would make the function equal 0. It's just not possible using what we call the real numbers. And so with this, we'd just say no real solutions. So today you got 5 problems. Throw them into Desmos, graph them, write down the x-intercepts. Now, for your work, even though you're using Desmos, you do want to show, like in this case, you'd make a quick sketch of the graph. You can find that vertex point. It looks like it's 6, 2. So somewhere over here, 6, 2. And just show it opens up. If you were going to